Alright, so I assume everybody knows this picture. It's Purdue campus. Okay, so the right side is that MSEE, as you can see. Right, this is the fountain. Right? Okay. Now why do I want to show this? I want to show something called metadata. If you go to property, depends on how this picture is taken, which camera this picture is taken. In this case, the metadata has only basically two pieces of information, width and height. I will try to find the examples where sometimes you have additional information. I don't have the pictures here, but if you take pictures, use your camera or your smartphone, and you log out your computer in Linux, use image viewer. So this program is called image viewer. In Linux, and if you go to image, say properties, you can see what we call metadata. The word meta, M-E-T-A, if you add the word meta in front of something, means the description of something. So, okay, let me explain that. Means the description about X. That's what meta means. So metadata means the description of the data. What's the data for image? Pixels, right? Colors. That's what you can see. But in addition to the data, you also have metadata. In this case, you have width and height. And as I said, it depends on the cameras you take. I have a camera that will tell me what's the speed of the shutter, is the flashlight on, and so on. And some of the cameras you have may also tell you GPS location, or the date, time, and so on. The information is taken. That's called metadata. Any questions about this? Sometimes, as I say, in general, if you see the word meta in front of something, it means the description about that thing. So why do we talk about this? We'll start talking about what we call programmer-defined data types. We've seen some building types, integer, character, double, float, and so on. They are useful in many cases, but they are not sufficient. Because in many cases, you want additional things. You want to put things together. For example, you want to create a type of student. You want to put name, age, GPA, and so on together. They are related. You should not have name, age, unrelated. Right? This is per student. You may have another data type that's called image. I'll talk about syntax in one moment. You may have, let's say, width, height, and maybe, let's say, you have your pixels. You want to put related information together for better organization, right? When you have let's say you have a drawer, you open a drawer, you have folders inside, right? You want to have things organized. Without user-defined types, it will be difficult to organize information. You don't want to say width is an integer, height is not integer, and they're not related. Once you do that, it's harder to manage your program. What's the syntax? There are different ways to define user-defined types. This is the way I prefer to use. You say type-defined structure. This means structure. For some reason, when C was designed, the designers decided to make it a bit shorter. So type-defined struct, open brace, and you have your data inside, and close brace, and this is the name of the type. So image is a new type. Don't forget the closing semicolon. If you forget closing semicolon, GCC will get confused. And you can easily get 50 error messages because GCC doesn't know what to do, does not know what to do, and GCC will go crazy. So every semester I have students come into my office and say, I have these 90 error messages, I don't know what to do. And as I put semicolon there, 50 error messages are gone. Okay, so don't forget that. Any questions so far? If you create data type, okay, you notice that some of these two examples we have pointers. I talk about pointers in a moment. Let me first give you a data type without pointers. Let's say I have a data type called a vector. And I can have integer x, integer y, and integer z. In this case, I have a data type called a vector, and there are 3 integers. Each one inside we'll call it an attribute. Or basically the data item is called an attribute. I'm borrowing terminology from C++. Structure, you can say structure was invented before the concept class was invented. And today I will borrow some terminology from C++ or Java to describe these structures. Any questions so far? So how do we create, after we create type, you think about vectors, think about students, think about image, there are types. So you can create variables. I can say vector v1. I can say student s2. I can say image I3. Because there are types, you can treat them as just as integers or as double. Any questions so far? Yes, please.
Wait, so are you renaming them by doing that?
No, I'm creating a variable. Think about this. If you say integer
initialize it to
x,
anything?
x4, are you comfortable with this line, integer x4? You are creating an integer variable called x4. Does that make sense so far?
But we don't have to initialize it?
I'll talk about that in a moment.
Okay.
Okay. One step each time. Okay. Are you okay with integer x4? Is everybody okay? So this is a similar concept. You'll say vector v1, student s2, image I3. I want to first show you what happens in the memory. Then we'll talk about initialization. When you write vector v1, what does that mean? The compiler will go to look at your structure. And the structure says, if you can see over there, the other side, they have 3 integers. This will be on the stack because I'm not using malloc. So this will be stored at the stack. So compiler will say, okay, I'll give you v1.x, v1.y, v1.z. I'll give you space for 3 integers. Now the syntax is v1 here x. That means you are retrieving the attribute x. If you say, let's say this is 101, 100, 104, 108, I assuming size of int is 4. That's the reason the distance is 4 bytes. It's a simple address there. So if I say v1.x equal to -2, so I put -2 here. And I can say v1.y equal to 6, I put 6 here. And v1.z equal to 4, I put 4 there. You are Laura?
Yes.
Laura. Yes.
Laura.
You asked Laura. You asked a question about initialization. That's correct. If you don't initialize, without initialization, you'll be garbage.
have to be continuous as you showed? You just showed that.
Will it be continuous? The answer is yes, but you don't really care. Because you don't really need to worry about whether they are in the memory continuous or not. The answer is yes, they will be continuous. So how, and then in this example, I also created an integer variable x4. So I can say x4 equal to v1 dot y. So I have x4 here, and then this will be 6. Right? So what is that period? What does a period mean? If you have a variable v, in this case, I'm going to again use the terminology from C++ and Java. I'm going to call it an object. If you say v dot something a, what does that mean? It means you take the address of the first attribute. And then you add the offset from the first attribute to the attribute A, and get a new address. Then depends on its left side, left-hand side. Then you modify the variable at that address. If on the right-hand side, you read the variable at that address. So let me explain what this means. If I say v1.x equal to -2, v1.x, the address of the first attribute is going to be 100. So the address is 100. And the offset is the address, this one, plus whatever is in front. There's nothing in front, so I add 0. And the new address is 100. Because x itself is the first attribute. Then if it's on left side, I'm going to modify the variable here, so I make -2. If I say x4 equal to v1.z, so first I look at the right hand side, address of the first attribute is 100. And what's z? Z is the third attribute. So the address of z add size of integer plus size of integer. How do you get this one? Because x is integer, because y is integer. You add that distance.
Different characters, let's say like in student structure. Yeah.
Let me finish this one, then talk about different types. Is that okay? Let me finish this one. So this one will give you 8 because I assume size of is 4. Then you get a new address is 108. And then since on right hand side, so I will read the variable at address 108. and the variance is 4. Therefore, this one means x4 equal to 4. Any questions so far?
Who's the addresses?
Address of which one?
Yes.
What?
Both. The first one, second one. Who's the address?
Okay, so when you see V1, the first thing you do is to find the address of the very first attribute. Is that okay so far?
So it's the x.
Don't worry. Yes. So the first attribute is x, the second attribute is y, the third attribute is z. When you see V1, you first say, let me go to address 100. Okay? Then you see x. X is the first attribute, so you don't add anything. Okay? Then you get new address is 100 because 100 plus 0 is 100. If you do z is the third attribute, so you add the size of the attribute in front. So first you get 100 because V1 start with address 100.
Okay.
And x size is integer, so you add size of integer. Y size is integer, you add y. You get 8, so you get address 108. Then since this is the right hand side, so I'm going to read the value at address 108, and it's 4. Therefore, this statement means x4 is equal to 4. Does that answer your question?
Okay.
Okay. So let me answer the question about if you have a different types inside for the attributes. Now consider the scenario. Let's say student. So when you say student, S2. Again, this will be on stack since I'm not using malloc. So compiler will look at your definition of a student. You will have s2.name, s2.age, and s2.gpa.
So does the order matter?
You don't really care because the compiler takes care of it. If the compiler reorder it, it doesn't matter. You will
Do you
calculate
have
for
to
you.
remember the order?
You don't have to remember the order. Let's say compiler free the order, and you say I want GPA. Compiler will know it's the second one, so you don't have to remember the order. You just use the s2.gpa. Compiler will find the correct one. So if you want to see, let's say this is 200. And maybe let me give a more example here. Okay, let me change this one. Okay, change this to double. And then I add another one. How about the character star, your address. So I have s2.address, means your home address, right? It's not address in the memory. So suppose this is from 200, and then suppose name is 4, so assume, then this will be 204. Because I take the address 200 and the size of the first attribute. So this becomes 204. Now assume size of integer is also 4. This will be 208. Size of double is 8. This will be 216. So the general rule is the following. You have a variable .a, the address of A is the address of the first attribute plus summation size of the attribute before A. So suppose the address start with 200. Since there's nothing before name, name is the first attribute, so it's 200. Age, the address of age is going to be addressed the first attribute plus the size of character star because the first attribute is character star, and just keep adding. But again, you don't really need to know. I know many people will ask, so that's the reason I explain. What you're going to do is you are going to use this notation, period. Okay, any questions so far?
Does the structure types have to start with capital letters?
Okay, good question. Should you start with capital letters? Yes, that's a convention.
Convention or rule?
That's what people usually do. You will start with an and, also it is a noun. That's a convention people use. Yes, please.
You're going to try to assign to that, like, for instance, if you did student S2 equals to, would that give you a warning or an error?
Student S2 equal to something?
Yeah.
Okay. I'm about to get there. Okay. Any questions so far? Okay. So now if you look at this, name is going to be a pointer, so you are going to do something like this. The length of your name plus 1. Why do you need to plus 1? Because you need to accommodate that character. Right? So that way, your name will have some address somewhere. Let's say it's 50,000. It will be in your heap memory because I'm using malloc. Suppose you give enough length, then you can say strcpy. What's your name?
Mine?
Yes,
Brian?
Brian. Okay, can I use your name?
Sure.
So then you have a B, R, I, A, and don't forget /0. So you have, this one has, length will be 5 plus 1, you have 6. Why do we do that? Because it's a pointer. Sometime later, you need to release memory after you don't need it anymore. Malloc followed by free, the rule. You can also say something like s2.age. How old are you?
19.
19, okay. So then put 19 there. Notice that age is not a pointer, so we put in the stack directly. Any questions so far? Okay. Now let's talk about assigning objects, since I call this object. Any questions so far?
Can you show the top part of the program you wrote? Is it inside the main or not?
No, I haven't written main yet.
Okay.
But I'm writing program. If you look at the program, maybe. So I can say s2.name equal to malloc size of 6. How do I know 6? Because I know Brian has 5 characters. That would be the code you would write. Or you can say s2.age equal to 19. Does that answer your question?
Yeah.
Okay. I can also say vector, okay. So I can say v1 dot x equal to 2, v1 dot y equal to -6, v1 dot z equal to 4. Okay? I can create another vector object v2. I can say v2 equal to v1. That's valid. That's valid syntax. What this means is the compiler will copy v1's attribute to v2's attribute. And moreover, copy the attribute one by one. It will do that for you. So after you do this line, it means v2 dot x is 2, v2 dot y is minus 6, v2 dot z is 4. Right, stay with me. I haven't forgotten you yet. Okay, about assigning. Because it's more complex, so I need to take one step each time. Okay. So remember, we are not doing malloc for v1 and v2. Therefore, when I write vector v1, vector v2, I will have space in call stack. I have different space in the call stack. First, I assign 2, 6, and minus 4. That's what this 3 line means. These 3 lines assign 2, minus 6, and 4 to the attributes of v1. The next line here, say v2 equal to v1. That means I'm going to copy the attribute by attribute to be 2. Did I say minus 6? Actually, sorry. Minus 6 and 4. And after the copy, they have different memory, different memory locations. Therefore, if I say v1.x equal to 2014, then v2.x is still 2. So if I say v1.x is, I change this one to 2014. v2.x is still 2. So did I answer your question about signing? C allows you to assign an object to another object, but C does not allow you to compare them directly. You have to compare them. You cannot do that. You cannot, C does not allow you to compare them. You have to write a function to compare them. It doesn't allow you to do that. You cannot write that line of code. Compiler will say, I don't know how to do. You have to do something like the following. So I will put into comment. Okay. You have to write the following. You will say, you write something like this. You will say, if v1.x return 1 if they are equal, return 0 if they are different. You need to write your function.
But the only 1 by 1?
Yes. Well, why can we do one by one? Because they are primitive types, they are integers. Therefore, compilers knows what to do with the primitive types. The type vector is what you created. Compiler doesn't know how to compare it.
Is it possible to create something like a for loop and then increment that compare address value?
Why do you compare address?
I mean, the values of the address. I mean, not typing every single.
Well, currently we don't have an array, so loop would not be a good way to do it. Does that answer your question? Okay. Thank you for asking questions. I'm sure that helps a lot of people. Also, you notice that since we talk about the convention of naming, the functions should start with a verb and is a lowercase. That's not strict rules. It means if you don't do it, it's not wrong, but that's the way people usually do it. A function's name starts with a verb and a lowercase. The structure's name is a noun and the uppercase. That's a convention. Obviously, if that's not allowed, you cannot do this either. You have to write your function.
You said you can do the function because they have the same type.
Because x, y, z are primitive types, are integers. So compiler knows how to compare them.
So if you have the student structure, like you have a char star, you have integer, you can do this?
If it's primitive types, compiler knows how to compare them. If it's a type you create, compiler does not know how to compare them. Therefore, you have to create a function and tell compiler how to compare them. So if you want to write another function, let's say, maybe I should add vector. So you can say, is student equal? Then here you'll say, student, S1, student S2, then okay, so let me show you the structure of student. So you say two students are equal only if the students' name are equal. So you can say if string comparison let me see where I can move this. Maybe I just do that. If their names are different, they are different, right? If their age are different, they are different. Now GPA double it will be a bit tricky because double has finite precision. So if you do this, even though it's the same student with the same GPA, because of finite precision, you may have a problem. But let's not worry about that for now. Then you may say, if the address and then if they all match, finally return 1. Does that make sense? Then how do you compare them? You will say something like the following. Here I create S1, V1, and V2, right? So I can say, let me put it here. I can say if is That's how we call it. This is how you can call it. Any questions? Yes, please. Thank you.
Oh, what does that say over there?
Which line?
Left,
Left side or right side?
the right side.
Right side,
The
okay.
If string compare s1 dot address, comma s2 dot address. Can you just go
Not
over?
equals 0.
Not equals 0.
Yes, because I'm doing string comparison. I should be able to score. I want to show them side by side, that's the reason. Okay. Not equal to 0, like this one.
Okay.
Maybe I just move on to next line. How's that? Is that better? Because string comparison, if they are different, it's not 0. If they are the same, that will be return 0.
Can you show how to, I mean, does this program work without main as well?
Oh, of course you need main.
Okay. And can you change the values of the vectors and the variables that you create outside of the functions, inside the other functions?
I'll get there. I'll talk about function, calling function with object in a moment. Okay. You're ahead of me. That's good. Other questions? Any other questions? That's one thing I always find is usually students are much smarter than I am because I usually have a lot of questions. Students usually have very few questions. I guess that's true. When I'm in a meeting or go to a seminar, usually I have questions. Students don't have questions. So some people say humans are getting smarter and smarter. Have you heard this? The whole human being is getting more and more intelligent. So I think I can already see that because younger people are more intelligent. Okay, so going back to your question about calling function with object. Okay, now you can see I'm calling a function with an object, right? So what is that? How does that work? If I call a function, let's say I have a vector v1, a vector v2, and sometime later I call a function, let's say is equal v1, v2. It's a function. How does that work? Remember, in a function call, every time you call a function, you'll do what? Kyle? Every time you call a function, what happens?
Pass everything in the call stack.
Put things on the call stack. Okay. So you have call stack, and then you have a frame. Then you have a v1. You have your argument. So you have the integer. I'm going to call a different name. I'm going to call u1 because that's u2, okay? So I have u1.x, u1.y, u1.z. And u1, u2.x, u2.y, u2.z. What's the value of them? I will copy attribute by attribute, one by one. Inside my main function, I have v1.x, v1.y. Actually, I'm running out of space. I'm just going to put it under. I'm going to copy them one by one. So this one will copy to here because v2.x will be copied to u2.x. And v2.y will be copied to u2.y. and you can do things inside if you want. So to answer your question, if I understand your question correctly, what happens if I change U1 and U2 inside, right? If I say U1.x equal to 18, today is what, February 18? I change this one to 18.
But you can still change the, do you have some syntax to change the value outside?
No.
Because in Java you can put this dot something and
Yes,
then change.
Java has call by reference. C does not.
So you cannot,
You cannot. The only way you can change it is you give the pointer.
yeah.
Okay, so C does not. Yes.
Like if you pass S1, S2 over here. then-
S1, S2, you mean U1, U2, or V1, V2?
No, instead of V1, V2, if you pass S1 and S2.
I don't have S1,
If we use
S2
the
yet.
other function, the is student equal, and we pass S1, S2 to it, then the pointer's address is copied, right?
Yes, okay. Again, you are one step ahead of me. It's good. Okay. So you copy attribute by attribute. If you change something inside, you do not change here. It follows the same rule as you do for primitive types, integer. Okay. Let me answer Muhammad.
Yeah.
Question first. If you want to change V1, V2, what do you do? You give pointers. You'll say, let's say I will have a function, let's say increment vector. I talk about syntax in a moment. Then I will say increment. I call a function with the address of V1. In that case, the call stack will be look like the following. Let me put 200 here, 204, 208. I'm skipping this is in the below, since I assume you already know that. Let's say it's 2 minus 4, minus 6, 4. When you give the address of a V1, this will be the address of 200. This will be the address of the first attribute. Because I'm giving this ampersand, so I'm getting address. U is only a pointer. U is not object, so there's only one thing on the code stack. So this is the place where students get really confused because of the syntax. You need to use U x equal to, let's say, 18, and U y equal to 2014, and uz equal to, let's say 9. It's 9 o'clock. If this is a rule, if it is an object, use period to get the attribute. If it is a pointer, use minus larger than to get the pointer, to get the attribute. So it will be something like the following. I show you and then go back. It's going to be at the bottom here. The rule is the following: if it's a pointer, you use minus larger than. There's no space in between. If it's not a pointer, use period. Why is that way? That's the way C was designed. Yes.
In C++, instead of using minus larger than, we can even use brackets with star u. Can we do that in this?
Yeah, can we do it? Can we use star? Let's say star u dot x. So
Okay. You mean this one?
Yeah.
You can do that, but I don't recommend. It's actually difficult to understand. This one will be clear.
yeah, of course.
Okay. Because when you do star u, basically you are already getting the address and treat it as an object.
How about if you send? I mean, is it possible to send pointer to pointer with vectors? Is there-
Yes, you can do that. Okay, again, you are ahead of me. Let me answer his question first about passing object with pointer. Okay. Can I answer his question first? Okay. Is it clear to everybody what's going on here? If I want to modify an object inside the function, I have to give pointers. Any questions? Yes, please.
You're giving an object filled with pointers.
Excuse me?
So you're giving a pointer to the object, or you're giving an object filled with pointers
This is a pointer,
to the
and this point to the address of the object.
Gotcha.
Does that answer your question?
So after you point to the address, everything with the object operates normally.
Just like
The
yes.
object would.
So if you write this one, okay, maybe that's the question. Let me see whether that's the question you're asking. What does this mean? Means this line means take use value as an address and let's say add the offset of the attribute. So what's the offset of the attribute? We said it earlier. Is that summation thing, if you remember? The address of an attribute is the address of the first attribute plus the summation of the sum of size of attribute before this attribute. So you have a y, that will be at the size of x. You have a z, that will be the size of x and y. And then again, play the same rule, depends on left hand side or right hand side. Left hand side means modify, right hand side means read. Does that answer your question?
Thank you.
Why don't you need to declare x, y, z in the function?
Why do I declare x, y, z?
Is it because you?
Because vector already tell compiler I have x, y, z.
Okay.
But this x, y, z is not in a call stack in that frame. This x, y, z is on a different frame because u is a pointer. So you point to the address of the first attribute. Okay? Does that answer your question? So let me answer his question where we have a pointer as an attribute. That's a very important part. But before I move on, any questions about this? Alright? So let's consider student object. So going back up to student. Student has name, address, and so on. So how would I create a student object? Let's say student S1. And I say S1.name. There's another function called string duplicate. I think we have explained that before. This will do malloc for you. So let's say Kyle, how's that? Is that okay?
Yeah, sure.
Alright. So this one will malloc for you.
Free.
No, you have to free yourself. And then you say S1.age. How old are you?
19.
19, okay. Let me just consider 2. Okay? Yes.
Does That function needs to know the size at compile time or can it be a variable?
Which one?
As or string dup.
Still, no, you will, so string duplicate, basically you will do malloc size of time.
So it can be a variable instead of Kyle.
Oh, it can be a variable.
Okay.
Yes. And whatever you give, +1. And then do a string copy. Basically, it does the two things for you. You have to allocate, you have to release memory later. Okay? So now if I call a function, let's say I'll call a function called print. Notice I again use verb to start with the function name. That's a convention. And I use lowercase. That's a convention. Then I can say print f. I print the name. So I create a function. Before I call a function, I have S1. So S1 is in my call stack. That's considered in the main function. I have S1.name and S1.age. strdup will allocate memory for you. If you don't believe me, I can show you the main page. Okay, as you can see, memory for the new string is obtained with malloc. So you will allocate memory for you. That means if I call strdup, I'll get some piece of memory. Let's say this address is 100. I give 50,000 here. This is stack. Oh, yeah. In a stack, in a heap, you'll be then since the pointer, I assume pointer to size 4, so this will be 19. So this will be what looks like in your call stack when you do this. Then when you call a function, you have S, so this will be in your frame, print, student. You have S. S is not an object, therefore S will also have the attribute. And you will be copying one by one, so this will be copied here. This will be copied there. So did I answer your question? What happens if you have a pointer in the object? That's when you copy one by one.
I don't understand why declared functions outside of any function is accessible inside a function, but then let's say int explore is not accessible in. Is there any function that should?
Well, I assume, okay, here are you talking about these global variables? No, I assume these are inside function.
Oh, okay. No, they're
Sorry for
inside a
confusion.
function.
Yeah, everything is inside a function.
Oh.
You cannot create anything outside a function.
Oh, you cannot create anything else. Okay.
No, that will become global variable. And global variable. If you are born after 1973, you should not use global variables.
Okay.
Sorry for confusion. Does that answer the question?
Yes.
Okay.
Yes.
Yes.
The name is character.
I cannot hear you.
The name, the S1 dot name, the name is character. Why don't you need?
Name is a string. It's a pointer.
Yeah. Why don't you write S1 minus larger than name instead of?
S1.
I mean, you wrote
S1 itself is not a pointer.
Uh-huh.
I don't have a star here. Therefore, I use period.
Okay.
Does that answer the question?
Kind of.
I don't have star here, so I use period. I don't use minus larger than.
So inside print, you can't change any of those values.
Inside the print, you can change. For example, for some reason, you want to say, let's say, make Kyle be older. Let's say age is 22. Okay, he's about to graduate. What do you change? You change this one to 22.
Right, but you can't change the original.
You cannot change the original since I'm not coding with point. I'm coding with the object, so it's a copy. If I want to change, I need to give a pointer.
But if I create the name, it will print S1 as well, right?
If you modify here, if you say free s dot name, is that what you want to do? So s1 dot name is 5,000. So you release this memory. When you get out the function, you are in trouble because
You still have that.
this variable is still there, but that memory is already released. So yes, you will have trouble. Okay, so that brings me to the next topic is, remember I said earlier you can do vector 2 equal to vector 1.
Did you? I'm sorry.
Yes, go ahead.
Can you go up? I'm again confused about. Why are you declaring them? So you're not assigning anything type this
Which line? Higher, here,
Line higher
higher.
than main. What do you do there?
You are creating types,
Okay.
and they are not. They just say there's a type. You don't have any variable yet.
Okay. But you can.
And here you are creating real vector. You are creating a vector, just like, okay, borrowing the terminology from C++, you are creating a type, but there's not instantiation. Have you heard this term?
Yeah.
If you look at, you create a type. This is a type. If you write vector v1, you create
Object of type vector.
you instantiate the type.
Yeah.
So let's consider a student. A student is a concept. There's no such thing, real thing as a student. You are a student, you are a specific student, right? He's another specific student. So you are an instance of a student. He or she is another instance of a student. But a student is an abstract concept. There's no student by itself, right? There is no car by itself. You'll say, I have my car, you have your car. Then each one will be an example of a car, an instance of a car. Does that make sense to you?
Yeah.
Okay. So again, borrowing the terminology from object-oriented programming, this is the instantiation of a vector. Just like when you write integer, what is integer? Integer is a concept. There's no such thing as an integer unless you create integer called x. Now you have an integer called x. Okay. Any other question? Yes, please.
Actually, the actual like typing of the like type def struct, would that be in like a file, or
That would be what?
where would you actually put that in?
You're put into, very good question. So where should this be put in? This will probably be put into called student.h, and this will be called in image.h.
Oh,
You'll put a type declaration inside the header file and include that header file.
inside the header file.
Yes. And here you will call it vector. That's a convention.
Can we put them all in one header file?
No, that's a bad idea. Here you will say include student.h. The convention is lowercase file name. You put everything in one header file, something like you put everything in a single drawer. Do you have multiple drawers at home? Okay, you want to organize them, right? So you put everything in a single file, that means everything is in a single drawer. Your book, your note, your code, your everything. That doesn't look good.
Does C link, let's say I include answer.h, and then in answer.h header file I have include student.h, vector.h. Is that
Yes, you can include multiple header files in the same C file.
Can you explain how typedef works over here?
How typedef is?
I mean, like what it does over here.
Typedef tells compiler how much space you need for that type. So if you say typedef x, integer y, integer z, that tells compiler I need to have space for 3 integers. If you go up to the student, you say typedef structure student, compiler knows you need to have a pointer, integer, float, another pointer. Does that answer your question? Yes.
Does it matter if you put like the same variable inside the type structure? Like first one, char star x, integer y, double z.
Wait, stop. Where? You go too fast. I cannot follow. Go ahead.
So char star x.
Which line?
The student.
Student?
Yeah, you char x and next line y, next line z. So you basically have the same.
I still don't understand. You mean this one?
Sure. So you have sim x y z as the next vector structures. Does it matter?
Doesn't matter.
It doesn't matter. Okay.
Doesn't matter. Actually, that's a very good point. Each structure is self-protected. So you have x, y, z in student, and you have x, y, z in vector. That's fine. They are not related in any particular way. Not related. Yes.
Can we use?
Thank you. I don't think you asked question before. Thank you. That's keeping an end. Yes.
Can I use this kind of self-defined type as the return type of my function?
What do you mean self-defined type? What do you mean?
Like vector?
Vector. You mean programmer-defined types?
Yeah.
Because later on we'll talk about self-referring structure. That would be something different. Can you put this in?
As a return type of
Yes.
function.
Yes, you can do that. You can say, okay. Again, you are ahead of me. Now, for some reason, students can read my mind. That's amazing. You can say vector. Okay. That's a bad name. I'm going to change the name. Yes. Does that answer the question? Okay, now I create a concept here, again borrowing terminology from C++ and Java. I call it a constructor. You should try to write constructors for your structures. For a very simple reason. In this case, your vector has 3 attributes. And then if you want to create a vector, you will say, let's say this in your main. you'll say vector v1 equal to vector construct. Let's say 2, 6, 4. It is better than the following for you may not feel the much difference right now.
But then, isn't it lost after it returns? It doesn't. Oh, it returns B. Okay.
Okay. How do I move up? Just a little bit. Okay. There we go.
Why did you write that in uppercase?
Which one?
Vector construct.
Okay, I'm using the way C++ and Java does. This will correspond to their member functions. And I write vector in front, say this is a constructor for vector. Because later on, I may write a constructor for student. Let's say student. That way it's clear which constructor I'm referring to. So I put a type in front, then verb later. In C++, it will correspond to this. Of course, in C++, the constructor is the same name as class. You don't have to worry about C++. I'm simply telling you to make it clear. You have the type in front. That will make it clear which structure you are referring to. Yes.
Should I declare the function vector construct in the header file in some way?
You need to you need to declare in header file the yes. So this will still be in the header file. So you'll say vector.
Oh, that's in the header file?
Yes, still in the header file.
Can we write the function in the header file?
Can you what?
Can we write the function in the
No,
header file?
you should write the function in the C file, not header file. Did I answer your question?
Yeah.
Yes, go ahead.
Does C use strong typing in that you can't like mix a like for instance x in vector is an integer, but age in student is also an integer. Can you mix those two?
What do you mix to?
Like if I took student.age plus vector dot y.
You can do that. I'm not sure how you want to do that, but you can do that. This is the integer. Okay. Yes. I'm not sure what's the purpose, but since they are integers, you can do that.
I just wanted to let you.
Okay. So why should I create a constructor? Now, remember at the beginning of the semester I told you, throughout the semester I will tell you many ways to make your life easier by writing programs that are easier to debug. And for those people that are not here, they usually spend a lot of time debugging. Let me finish. Give me 1 more minute. Whether you like it or not, there's something you cannot change. Is your program will change. Maybe you find a bug. Maybe your manager tells you we need to add a new feature. Maybe your computer has a new feature. Maybe your manager's manager says I don't like it. No matter how much you try, your program will change. That's a fact of life. So, if one day your manager comes to you and say, you know what, I think we want to have another attribute in a vector. How about we add a time? Because now we are doing animation. We have location X, Y, Z, and I have time. I need to know where it is at a particular time. So, you say, okay, great. Now, in the vector, I add a time here. Okay? You add time. Then, if you do the second way, guess what? You have a very good chance you will forget to initialize time. Trust me, I've seen that many, many times. You will forget to initialize time. What you should do is you should create a constructor and say, I initialize time. And if you use the first way, if it turns out you forget to initialize time, the constructor needs 4 arguments. It only gives 3. compiler will tell you. Compiler will tell you you forget to initialize time. But if you use the second method, compiler will not tell you.
So is it just gonna be garbage value?
It will be garbage value. And this kind of bug is very, very hard to find. Trust me. Very, very hard to find. Because sometimes maybe it's zero, sometimes it's strange value. Your program behavior will just be strange. Compiler errors are good because you can debug before you run the program. Segmentation faults are good because the program will crash. The kind of bug they are hard to debug. They take you a lot of time, and the bug or your program behavior is inconsistent. Sometimes it works, sometimes it doesn't. That kind of bug is very hard to find. So what do? You prevent that bug from happening in the first place. If you create a constructor, your manager says, I need to add time. You go to modify your constructor. Any place that goes constructor and then forget to add time, you get compiler error, and you remove that mistake right away. If you do the second way, initialize attribute by attribute, you will forget. Trust me, you will forget. And you will spend a lot of time debugging. Does that make any sense? Right? That's why some people spend 4 hours, 5 hours, 6 hours for assignment. Somebody spend 20 hours debugging because they are not following the rules. Okay, any more questions? We have based on my clock, I have 3 more minutes. That means, I think that was your question. What happens if the object itself is, if I want to create something like vector v, not in a function, I just want to create vector v, similar to I have, then I will say v equal to malloc so which means in my stack I have a v. V is a pointer.
What is size of vector then?
Size of vector is a summation of attribute. Size of attribute. Compiler will do that for you.
Will there be anything in addition to size of attribute, like to say that it is a object?
Okay. Yes and no. Compiler may add some additional space for efficiency reasons. Because sometimes it's not aligned to boundary of 4. Compiler may add space, but you don't care. For our purpose, just remember it's size of. Okay. Sometimes if the attribute is a character, depends on the compiler, depends on optimization. Maybe you'll say, I want a character. Compiler will say, I give you 4 bytes because it's faster for some machines. Because 4 bytes is faster for the operation. Okay. So when you do this, you will become, let's say you get 10,000. This will be X, Y, Z if you have time. So after you do this, you will say V, because now V is a pointer, so it needs minus larger than equal to 5, and you modify this to 5. Of course, later on, you need to say 3. Did I answer your question? If you want to do student, you can do student too, but you need to have 2 labels. Because student has vector, has pointer as well. You say S equal to malloc, size of student, and you say S name equal to malloc. Depends on how much space you need. Size of character times length plus 1. Later on, you say free name and free S.
Can you go?
The order had to be reversed. What you allocate first has to be released later. Because once you release S, you no longer have name. That doesn't exist anymore. Therefore, you get segfault. Yes? I saw you raise your hand.
Can you show the call stack there?
In this case,
No.
this one.
Yeah.
Okay, you just want to write? Okay. All right, we are running out of time. We have a lot of material today. Please read the class note. And Thursday, I will return the exam, and we'll talk about how to read and write structure in file. That's what you need for the next assignment. So next assignment